Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today as it is every day here in my virtual classroom. As you step on inside, I'm beginning a new unit with my integrated math 2 folk, and we're looking at things involving polynomial expressions. In this one, specifically, we are just combining like terms. We're going to be adding and subtracting polynomials that already exist. Now, they come in weird forms sometimes. They'll be quantified. We'll see sets of parentheses here and there. Let me show you what they look like actually right now as we just dive in. So I'm going to be doing 10 total problems. I'm going to be doing the 5 that are circled here, which are all through addition. And then on a couple pages here, I have 6, 7, 8, 9, 10, and these are done through subtraction. Now, when I say addition and subtraction, I mean how they have a minus in between the quantified sets. This minus this. So why do they do that? I don't know, just to kind of quantify sets there. I think for subtraction, it's important to talk about what it is it's going to look like, and we will. And for you to know this stuff here, I know I'm kind of skipping a section when it comes to solution guide video stuff. The last things that we did was we looked at identifying what a polynomial was, where they have exponents that are whole numbers with their variables. We talked about writing items in standard form, and I'll be talking about that one here. The leading coefficient, the way to name the terms and stuff like that. But now we're going to be combining like terms. And so what does combining like terms mean? Well, when we have variables with something, there's a way to simplify the expression, to make smaller, get rid of parentheses, get less x's all involved together, all depending on kind of what's there, and just combine them through addition and subtraction. When I have 2x, what that means, it means 2 times x, and you know that multiplication means adding something to itself over and over. 2 times x means x plus x added twice. 3x means 3 times x, or x plus x added 3 times. What happens when you add 2x with 3x? Well, the idea is you're taking 2x's that added together, and we're going to add that with 3x's added together. And you know you get a total of 5x's added together. 2x plus 3x equals 5x. This is an idea of combining like terms. 2 terms that have the variable x in it of degree 1. This is x to the first power here. And 2x's added together, 3x's added together gets us 5x's added together. That's simplifying 2x plus 3x to 5x. That's what combining like terms means. Keep the variable, add the coefficients, boom, you're good to go. Now you can't do that with something like 2x squared plus 3x because this is 2x squareds adding together. This is an x times x plus an x times x, and then plus some x's added together here. When I ask how many x's are added together, these are together here first before you add anything as well. So, you just got to be careful as far as combining like terms there. I can't combine these together. This doesn't become 5x squared. These don't combine. When you combine like terms, you need to have same variables with matching degrees. So the degree, the exponent of 2 means this term is of degree 2. This exponent of 1 means it's of degree 1. They need to have matching variables with matching degrees within their terms. So we'll see if we can make sense of it. I'll make sure to dispute and let you know when things do and don't work, and I'll show you how to get rid of these parentheses because honestly, we almost don't need the parentheses for any of the addition problems here. Let's start with number 9. Negative x squared plus x, that quantity, plus the quantity x squared minus x minus 1. Now again, why are the parentheses there? You got me. I have no idea. I have no idea. What I can say is that we can safely remove the 1 so long as it's just addition that's occurring here. Because what happens is when we add a positive, we're left with a positive. When you add a negative, you're left with a negative. When you add a negative, you're left with a negative. Basically, the signs that you see are the signs that they will become. If you're completely uncertain on what to do there, you can also maybe put a number 1 in front of here. 1 times something is just that something, right? So if you distribute the 1, and 1 times negative x squared is negative 1x squared, so that's just right there, and 1 times x is just x. Basically, the parentheses are gone in that instance. So, you got me as far as why they actually put them, but they were there. Distribute the 1 into these. Case in point, I'm going to have a plus x squared, minus x, and minus 1. I'll talk more about distribution of stuff when we're referring to the negatives when we get there. So anyway, I'm just rewriting it right now. I don't know if that's a requirement for my own kiddos to do as far as the step goes, but I think it's an important one to state. That, yeah, parentheses can be relatively ignored when it comes to the addition of a quantity. Okay, So now what we have to do is we have to combine like terms. Now what I'm going to do on some of these problems to begin with is I'm going to group terms that are actually alike first to just help you out a little bit. Let's find the x squareds and let's write them next to each other. I'm going to reorder the terms. I'm going to put the x squared terms together first. I got this negative x squared here. And now I'm going to go ahead and write the x squared right next to it. So I'm crossing these out to say that I put them in. I'm not doing something to both sides or whatever. I'm just negative x squared is here, plus x squared is there. Now let's put the x's next to each other. Plus x here, minus x here, and then minus 1 here. So I put the x squareds next to each other, negative x squared plus x squared. I put the x's to each other, x minus x, and I put this negative 1 right there. Now, if it helps, you can also put 1s in front of these numbers right here because that is their coefficient. Negative 1x squared plus 1x squared, that's actually what's occurring there, just so you're kind of well aware of the fact. And negative 1x squared plus 1x squared is 0. Those terms actually kind of cancel each other out. You get 0x squared. There are no more x squareds. They are gone. They are kaput. They cancel out. 1x minus 1x, same thing. That's 0x. They cancel out. They're gone. You know what you're left with? Just a negative 1. When all said and done and we simplify this thing, all that's left is negative 1. You can try and plug in a number and see what happens. When I plug in 2 into here, all these numbers are going to cancel each other out there. You're just going to be left with negative 1. That's kind of what's up. Anyway, we simplified that, and all of the, no, they're not supposed to all simplify like that. They won't all clean up in that way, but that first one did. Okay, number 10. The quantity a plus b minus c squared, and then plus the quantity a plus b. Once again, just kind of writing without parentheses and saying that, we're not distributing those or anything like that. We're just adding. All right, so I'm going to write variables next to each other that once again kind of, belong, if you will. I'm going to get a plus a next to each other there. And I'm not going to cross them out this time, but a plus a. Then I got b or plus b, and then this plus b right here. I'm going to write them alphabetically. And then I got minus c squared. Again, not a requirement, but it's kind of a way to say, hey, a's are the same variable. A's have the same degree. A's will combine here. This is 1a plus 1a, right? 1a plus 1a, keep the a, add the 1 and 1, you get 2. 1a plus 1a is 2a. That's how they combine. Those are like terms that combine. B plus b does mean 1b plus 1b. 1b plus 1b is 2b. So b plus b is 2b. They ask how many b's there are. There are 2 of them. And then minus c squared right there. And that can't combine with anything else, but that's our final result. 2a plus 2b minus c squared. Pretty straightforward as far as combining like terms. Yeah, you're trying to find things that match. Now, it can get a little more confusing. We look at number 11, and once again, I'm going to rewrite them without the parentheses here. ab squared plus b squared. Now, plus a negative, I don't want to write the plus and the negative, just one sign. Adding a negative becomes subtraction. So minus 2cab squared plus b squared. Now, right away, I have a little, there's a little hiccup that I have here that I don't love, and it doesn't look like it's actually going to affect the problem, but what I prefer to do is write my variables alphabetically. That way, if there are 2 terms that have the same variables and they look like they're in a different order, I would rather instead rewrite them in this order, like this, 2ab squared, and then c, like that, so that anything else that might match with it, I'm really aware of, so I'm not hunting for it. Whoa, this has a c written first. This has a c written last. It doesn't matter, as long as it has the same variables and matching degrees. So write them alphabetically, I think that kind of helps. So there's a reason for rewriting this step. All right, now here's the thing. Every single term that you see here has a b squared. I see a b squared here, a b squared here, a b squared here, and a b squared here. Does that mean these terms can combine? Not really, because there are other variables. There's a way of writing it where they combine, but it has a factor. Not really, not without parentheses. We're trying to do everything without parentheses. If they don't have matching variables with matching degrees in full, then they won't combine. This has an a, this does not. They will not combine. Because we're trying to add coefficients, numbers that can actually combine together. These b squareds can combine right here. You see this b squared plus this b squared? Those 2 can combine right there. 1b squared plus 1b squared will combine to get 2b squared. So those 2 in total, those 2 combined together, we get 2b squared. I have an ab squared there, and here I have an ab squared c. Because the c is there, it's not going to combine with the ab squared that's right here. So that's a minus 2ab squared c, like that. and then kind of just rewriting it all, and that can be an example of your final answer. Now, they did not ask me to write these things in standard form. I did say I would talk about standard form. I think I'm going to do it more with ones that have a single variable. Let me... Yeah, you know what? I can rewrite these in standard form for you. I don't know how much I do want to give a large explanation for it. But standard form of this one's fine. This is just one term. Standard form of these has to do with writing terms in what's called descending order of degree. And what that means is the degrees are based on the exponents in your variables in each term. And when something has a larger exponent, you're referring to something with possibly a larger degree as well. And you want those terms to be written first, alphabetically or otherwise. If it has a larger degree, it goes first. If there's a tie, I'll take things that are alphabetically first. But here, that means the c squared, this thing is to the second power, this 2b is to the first power, this 2a is to the first power. Because the c squared, this is to the second power, in standard form, that term would actually go first. A and b both have matching degrees of 1. So I'm going to write the A first just because it's alphabetically first. That's just what I'm going to do. So there's a standard form equivalent of that. They're not requiring it, but I'm giving you what that looks like because in a lot of times we are going to write things in standard form. I wanted to save it until we had one variable, but you know what? Something I'll probably ask for my class to do. So something that you can look at here. Standard form on this one's a little bit trickier because you have multiple variables within terms. When you have A, that means A to the first. And what you do to find the degree of a term is you add the exponents within the term. 1 plus 2 is 3, so this term is of degree 3. This is a 1 for A to the first. This is a 1 for C to the first. This is 1 plus 2 plus 1, which is 4. These exponents add to 4, so this term is of degree 4, and this term is of degree 2 because that exponent. If I want to rewrite this thing in standard form here, I'm going to have the degree form term written first. Negative 2, ab squared c. Excuse me. And then the degree 3 term written next, the plus ab squared. And then the plus 2b squared right here, the degree 2 term last. That would be proper standard form. Doesn't matter what the leading, or doesn't matter what the coefficient is in front of these things. It's from highest to lowest degree there. So okay, so I'll try and keep doing that each time. If you're too confused by it, I mean, you know, you weren't required to do it here. So I hope that those who do understand it can really make sense of it and use it. And I want to do it here because these have all x's in them, even though things may naturally cancel out. We'll see. But okay, so here we have 2x minus x cubed minus 2x squared plus negative x cubed, that means minus x cubed, plus negative 2x, that means minus 2x. So in terms of combining like terms here, I am going to go in standard form with this. So when you look at these, this is a degree. I mean, I don't want to say standard form stuff too soon. You can always combine like terms first and do standard form second. Yeah, you know what? Here, in fact, let's do that. Let's look at the 2x here. That 2x can combine with anything else that has just an x. X cubed, no. X squared, no. X cubed, no. 2x, yes. I got 2x minus 2x. Well, you know what? That's 0. So those will cancel out. 2x minus 2x is 0. Those are just gone. Wiped out. Now the negative x cubed. What can combine with that? This negative x cubed here. That's negative 1x cubed minus 1x cubed. That is not 0. Those don't cancel. That's negative 2x cubed. So that becomes negative 2x cubed right there when those two combine. And then there's the minus 2x squared. Then there's the minus 2x squared. It doesn't seem to combine with anything. And you know what? That's standard form as well, because when you compare these things, this is degree 3, and degree 3 is higher than degree 2. So this is written in standard form right there. Okay. All right, skipping number 13 is just too wacky of a problem. I'm just going to ignore it. I mean, this one's pretty rambunctious. There's a lot to do on 14, but let's see if we can keep our work organized and do number 14 here. So once again, I want to rewrite the problem here without parentheses. I know it's just a small bit to have it, but yeah, let's play with that. I will rewrite this in standard form after. All right, plus negative. All these are negatives. Adding a negative, adding a negative, adding a negative, adding a negative. Those all become subtraction. So minus 6qr squared minus qr squared minus 11q minus 3q cubed r squared. All right, so that's a lot of stuff. It's a lot of stuff. Okay, we got to find like terms that combine here. So I look at this 7q cubed r squared. I need to find something else that has q cubed r squared. And it needs to be exactly that. It can't be q squared r cubed. If it says r squared q cubed, that's fine. I would instead reorder those so it actually does say that. So q cubed r squared. No, 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 no. Yes, all the way down here. So 7q cubed r squared can combine with negative 3q cubed r squared. 7 minus 3 is 4. So with those two combined, I get 4q cubed r squared. 6qr squared, if I have another qr squared, here's one, negative 6qr squared. Okay, those two are going to cancel out. 6qr squared minus 6qr squared is 0. Those ones are gone. That becomes 0qr squared, and they're just gone. 21q minus, oh, I'm sorry, there's another qr squared here. I'm sorry. Well, okay, so these kind of do cancel out there if you take a look. But there's a minus 1qr squared right here. So time out. 6qr squared minus 6qr squared is 0. But I do have a minus 1qr squared right there. So I do still have this minus 1qr squared. I don't actually need to put the 1. You want to know that even without a 1, that's what that thing means there, because it didn't have one there. And then lastly, I have this 21q minus 11q. 21 minus 11 is 10, positive 10. So that'll be plus 10q. And you know what? This is also in standard form as well. When we consider the degrees of each term, 3 plus 2 is 5. This is of degree 5. 1 plus 2 is 3. That's of degree 3. And this is of degree 1, just being q to the first power there. So degree 5, 3, 1 in descending order of degree. We are in standard form. I'm kind of glad I said the standard form thing there. All right, those were the addition ones. Now we're going to dive into some subtraction ones. And the main difference really is just how the problem is set up to begin with. Now that we have those parentheses, we're going to be doing a quantity minus a quantity. And because we're separating the terms, taking them out of the parentheses, we got to do something with that negative, subtracting each of those bits. Anytime we subtract a positive, that's subtraction. But anytime you subtract a negative, it becomes addition. And there are different ways that I bring it up when I'm talking to students. Sometimes I just mention that literally, subtract a positive, subtract a negative. But then other times I talk about kind of distributing the negative, and a negative times this, and a negative, things like that. So the first quantity right here, 2x squared minus 2x to the fourth and number 3, that part doesn't really matter with parentheses. There's no number or sign in front of it. I can just write 2x squared minus 2x to the fourth. But the second one, you got to be really careful because we are subtracting the quantity. We are subtracting x to the fourth, and we are subtracting negative x squared. I kind of say distribute the negative. Negative's not a number, but negative 1 is, and you can treat that as a negative 1. What is negative 1 times x to the fourth? Well, that's negative x to the fourth. What's negative 1 times negative x squared? That's positive 1x squared. So you can see that subtraction here now, or the parentheses here, do matter because of the subtraction, and I'm distributing the negative, if you will, or subtracting each of those bits. Whatever was positive here, the sign changes to negative. Whatever was negative, the sign changes to positive. And that's where rewriting this, I think, is super crucial. And I wouldn't not do it myself as well. I would always put this step, so I'm going to. Okay, so here we go. Now we combine like terms here. 2x squared combines with the 1x squared right here. 2x squared plus 1x squared is 3x squared. And negative 2x to the fourth minus 1x to the fourth would give us negative 3x to the fourth. That could be a final answer, but in standard form here, that's degree 4. So I want to write that term first, negative 3x to the fourth, and then I have the plus 3x squared right there, if I do actual standard form. Now, this did say find each difference vertically. I'm not following their instruction thing. I'm going to talk about writing these as a simple single expression, not necessarily simple, but as a single expression, very long. When they say do it vertically, they mean put the x squared right underneath. And there's nothing wrong with it in nature, but at some point you're not dealing with expressions that way. This is kind of meant to teach you how you're going to do it horizontally later, because you deal with expressions horizontally. You do. I have some students who have this habit where just on the side they're writing like 2x squared plus x squared equals 3x squared. Now you're introducing an equal sign and things, and I'm just, just go step by step, keep your rhythm and flow intact, and I think you should be fine. All right, number 6. We have, so all these are subtraction, remember, in between here. So in rewriting this, I have x squared plus, now here's where I've mentioned the alphabetical order thing. See where this says y squared x? I'm going to call that xy squared. Remember, the squared has to do with the y, but I'm going to put that there. It's a consistency thing. I want to make sure I'm alphabetical because in case you have another thing that is different that says x than y, whatever, I want to make sure that it matches up. I want to make sure that I know that those are possibly like terms that can combine. Oh, and we have a z here. How lovely. So plus z. And then we have minus. So again, it's in a way, it's a distribution of the negative. Minus negative x. Subtracting a negative becomes addition. So plus x. Minus this xy squared here, a positive. So minus a positive becomes a negative. So negative xy squared. Hey, look, there is an xy squared. So you see, these two are going to combine, and that's something you might not have recognized when you write y squared x. So writing xy squared helps there. And then minus a negative z becomes a plus a positive z right there. So again, without parentheses, here's what we got. Let's combine like terms. Can x squared combine with anything? No, it can't. That doesn't mean you cancel it. It's just x squared there. Now I have xy squared, where was it? Minus xy squared. So those are exact opposites of each other. 1 minus 1 is 0. Those are gone. They cancel. Bye-bye. No more. So it was important to find those, combine them, and then you're good there. Plus z plus z. So 1z plus 1z is 2z. And then this plus x right here. So that could be a final answer. Now, if I were to consider standard form here, and really, I'll let you know, beyond some of these sections, we're probably not going to do much with multiple variables, but regardless. Standard form here, if I consider x to be alphabetically first and as a dominant variable, this is of degree 2, degree 1, and degree 1. I have a tie of these ones both being degree 1. I'd rather put the x term first, just as far as being alphabetically first and dominant in that form. So that's the standard form equivalent, guys, of that problem there. You can question why I'm actually doing that in that version, but that's a good answer for standard form. All right, I got 3 more problems, I do believe. So numbers 9, 10, and 14. All right, I don't know if that number 9 didn't really look harder. Oh, because they go horizontal. Whatever, I'm doing all of them horizontally. All right, so here we go. So let's see if we can do this without me drawing the arrows there. I'll say them out loud though. So negative 2x squared plus x plus 1 minus a positive 2x squared minus a negative x minus a negative 1. Subtracting a negative becomes addition. Look, everything's kind of a duplicate. Negative 2x squared minus 2x squared. That's negative 4x squared. Plus x plus x. 1x plus 1x is 2x. So plus 2x. And 1 plus 1 is 2. And that is standard form right there. This is an example of a quadratic trinomial. Negative 4x squared plus 2x plus 2. Degree 2, degree 1. Constants are degree 0. They don't have the x thing with it. That's equivalent to 2x to the 0 power. X to the 0 power is 1. It's gone. It's degree 0. Constants go last in a polynomial. But there it is. Standard form. We're good. All right, 2 more questions here. And we'll get this done probably 25-ish minutes. So a plus b minus 2c. Not a. A plus b minus 2c minus a minus b minus 2c. So you see what's happening here. We have an a minus a. Those are gone. That's 0. Those cancel out. B minus b. That's 0. Those are gone. Those cancel out. Negative 2c minus 2c. Those are... no, they're not. We got a negative 2 minus 2. That's not 0. That's negative 4. And that becomes negative 4c. And that's all it simplifies to. We've combined like terms. And that's it. One last question on number 14. It's one of the big guns here. We got those q cubed r squared things. Looks like I was really a big fan of those. So let's rewrite all that. Q cubed r squared. Remember, that's 1 q cubed r squared. Minus 6q r squared minus 21q. Hey, are these the same numbers? Are we dealing with the same problems, but now it's just subtraction instead? I have no idea. Minus a negative becomes plus. So plus q r squared minus a negative. Yeah, remember these minus negatives right here. Now these are pluses though. So plus 6q r squared plus 11q plus 3q cubed r squared. Should have looked closer at the problems and noticed that they were actually kind of samey. Q cubed r squareds, how many do we have? 1q cubed r squared plus 3q cubed r squared. 1 plus 3 is 4. That gives you 4 q cubed r squared. And if it's long like this, you can do that little, I'm not canceling them, so to speak. I'm showing what things I've already written, if that makes sense. So I know to not have to look back at those, I can skip them and not let it bother me. Negative 6qr squared plus 1qr squared, that's negative 5qr squared, plus 6qr squared. So negative 5 plus 6 is positive 1. So I'll have a positive 1qr squared plus qr squared. So that combined with that, negative 21q plus 11q, negative 21 plus 11 is 10, or negative 10. So that's minus 10q. And yeah, this might just be the opposite version of the one that we had previously. Anyway, that's in standard form there. And yeah, that was the last question on this guy there. So combining like terms, guys, once again, you need to find matching variables with matching degrees in each term. Try and write them so that the variables are consistent, so you have them alphabetically first and things like that. I do think that that really helps with you finding what combines. If there's no number in front of a variable, that means it's a 1 or a negative 1, depending on whether it's addition or subtraction. Whenever you have parentheses and something quantified and you're just adding it, you kind of just get rid of the parentheses, right? Just treat the signs as they are. You don't add everything, but adding a negative becomes subtraction. And then subtracting a quantity there, you distribute the negative, and then we change the signs of everything in there. Subtracting a positive is a minus, and then subtracting a negative becomes addition right there. So anyway, guys, that'll do. Oh, the standard form thing does descending order of degree. Add up the exponents in a term to determine that and rewrite them in that order if you choose to, if you care to. That ought to do it for this one, guys. This is Mr. Robinson. Thank you so much for watching those 10 problems. I sure hope that helps you. Take care.